I will have an introduction at the beginning showing the focus of this report and the contextual information. And then the main part is visual representation of knowledge structures with some examples and analysis, and the final conclusion. So what I'm talking about, visual representation of knowledge, how many ways can we present? I read a book and made this main framework, say, in general, when you represent knowledge, there are two main ways: quality-based versus quantity-based, but those are original, okay? And the sensitive ones are how people sense, and the intelligible one, how people can understand. The other side is the quantity-based. I have some examples. So if it's a sensitive, what we can see, based on what we can feel, the shape, the figure, the color, and even whether you feel, right? So I have some examples of this. Intelligible means that being able to be understood or comprehensible. Those including knowledge, attitude, intelligence. So those are the ones like ideas. You be able to understand the principle. The quantity-based, two main parts, I won't spend time to explain that, but in general, the geometrical versus physical and the multitude number aggregate numbers. And I use those examples to show what we can see that the knowledge were represented in visual way. I have the image sources listed in the last slide. So that is about this framework. Then the focus of this report is on the central part in terms of the quality-based and practical. And this is just an example of that, but also in the current computing phase stage, everything we produce, especially making interactable, also across the top, not just based on this. So the example you will see also later, I talk about whether quantity involved or not, how that will work. But this is just a general introduction of the focus of the report on this part. Then another example, the focus of this report is on the hierarchical structure. There are so many different ways to visually represent knowledge structure. And my focus will be hierarchical. Another explanation about the focus is this is the way we see in the computer, right? And we can see all the explanations and visualizations. Interesting thing is each of this, I will show later different shape, can trace the root back to more than 2,000 years. They are graphic presentation. They're not computerized. So if I will explain those original tracing the root of where the idea came from, that would take a lot of time. I will not talking about them today, but it's interesting to see how wonderful that all of this can trace back to so many years. And so this is about computerized and interactive is my focus. And what I will talk about this will make the tree shapes, circular shapes, and enclosure diagram as a three-part to talk, and not just the graphical, also we will think about the user experience design. We will think about how the features, this you will see this picture several times later. That's the focus of the report. There are two things additionally I want to just bring this back, say types of hierarchical relations, not just genus species relationships, kind of, but also part of relationships and instance relationships. So the three basic hierarchical relationships. Meanwhile, we also see a lot of polyhierarchical relationships. This is one of the contextual information I want to bring in. Another contextual information is about user experience design. And there's some normal methods that is referenced in this book in the 2012, all the UX design for libraries. It's very useful. It's mainly the usability testing, card sorting, personas design, the content audit survey, website analysis. And we have yesterday already saw our Maya and Tanya talking about, and this is what they have done previously to research. You can see this exactly the same kind of information, but presented in different ways and how user likes them, right? So there are two references you can have. One is my colleague Esina, Salava, and Tanya together. And that's a full paper. And previously, our Maya, Zuma, and Esina, they kind of made in Slovenia. So further, also testing in United States, where the people have different kind of user experience design thing. Very good, very interesting. This about bibliographical information presentation. So this is two actual information I want to bring you. So this course so far, talking about this, we will focus on the hierarchical structures of knowledge organization. In order to connect the theory and the practices, explore differences among applications, and discuss the functions of visual representations of knowledge in the layout that enable better information discovery and ultimate user experience in this data-driven age. So the second part is the major talk. The first reference is the one inspired me and made a website using examples, you will see that. And the other one is a book and also a taxonomy that I will use for putting what the graphical structure together based on this taxonomy. The first part would be on the tree shapes. We have the tree shapes, have 4 of them. The first one, the figurative trees, are very popular for many years. Genealogy and classification and the combination of the two. It's interesting that this is graphic in the computerized in navigation system, maybe not in this way, from top down or button up. Which way? We'll talk about that. What do I want to you think about and say with the tree structure only based on the logic, in the sense the order, structure, and size be both quality and quantity based. Think about that. And this only in the computerized stage, or we already had that before. Well, we're back to Leonardo da Vinci, already made based on very specific structure of the root, branch, sub-branch, and leaf. And this is the three other examples say which one more closer to what Leonardo da Vinci did. This one, or this one. This is more closer, follow his rules. Now think about if we see a structure like this on our computer, the modern tree visualization, what we ignored, you see that there's no space, right? Okay, so let's first see the visual trees vertical. We turn it down because in the computer time we usually don't see the figured tree have the rooted button. You maybe see from the top and continue go on. This inverted trees, the root are at the top. The layout showed here that all the nodes in a given layer are the same package depth. So what is a good one? We can see be a minimal wasted space. You can fully use the computer interface. But there are issues. Can you read any of the label? You have to go this way, right? And are these based on the grammar? Right, so there are some kind of issues like this. Now, the vertical trees, so we see the pros and cons, and there's some other way they make the label readable, but they are overlapping. So how can we advance, increase the readability? Well, the computerized, interactive, and the 3D technology now help a little bit more on this. Okay. Now, ISKO layout is the now we put this one original to this one. What's the good feature? Because it shows the size, you know, this class, this branch, the size can compare. But there are similar problems with the one we see. You cannot read, you cannot do as normal. So that's another layout. Now we turn into the horizontal tree, which is the most popular, and you'll always see that it gives you the simple the grammatical constructor of a sentence. So you can also explore open, open, open. But this is on the whole page, your screen, only one side. Did you waste any of that? So early on, there are already some other design shows you that this is the way, but I turn the other way. So not just one, but multiple and go on. So the advantage, the pros is that you may attach different data nodes and tips and go on with this. All relate to the hierarchy. You see the original, you see the breaking down. That's the example. But the issue is that I showed you this is the whole computer page, only one side has this. You wasted it. And if it's a long list, how long you have to go? Click, 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 right? And you have to go all the way down. Would this be, can this be solved? The other better way. So this is the advancement that I want to show the previously called Indiana philosophy ontology, but now it's called internet philosophy ontology. You click on that, you further go on, and also specific ones about the properties, about the impacts influenced by all of the showing up. But in general, is say, okay, not the same as the original. It is indented, it is horizontal, but it's much more effective. The horizontal trees also can use different colors and also can have quantities involved. How about this one? It's great. And not only I can show original, I can address Arabic, and then in the way they read. It's can be tailored for different languages. So those are the horizontal trees. What I addressed is where are the root, right? We check on the, and then how the branches, sub-branches, and leaves, final line. So this is about the tree shapes, most popular. Not only think about the root, but also think about the features, whether it can be extended, can be more readable, you feel comfortable. Next one, want to go to the circular shapes. Circular shapes has three. This, again, we change this same data into this. Many more, you can see how many details, right? This can be done, and with the design of the coordinates. So the the space on the computer is more used with the semantic sense of balance. This is the radical tree. Continue with this one. This is, you use the radical, it's only conceptual, logic, or it's also quantity. So I put the original source compared with the ancient Chinese 5 elements. It's all logic, or you can emphasize a particular part, but they are the conceptuals. About this one, it's already involved the quantity. Let's see the quantity. This was 1921. It's a graphic, and now also you can see in the quantity-based situation. You see the blue part, children's. Why they are spending so much time. You can see the second category that shows the numbers. So this means it's quantity based. And there additional marks can be made. This was one our schema.org just started. The use of this to show the major classes of schema.org. So the additional marks can be used. And also you may even see the official one. Yeah, You may see the official ones that they use to put this additional marks. And there's another robotic trees. What I mean, there's some parts you spend a lot of details. Is there any way that I can address particular parts? Originally, this is the radial trees. This is the sub-branch and the leaves. Now you can make it clear, bigger. You can see that. So this is called parabolic trees. This good for user experience or when you explore and whether people can find the route. So those are also need to be considered and continually considered. There are also a sunburst layout that addressing specific part. So instead of the original one, you cannot read, now you can go this way. So all of this can be done with computerized algorithm. And so getting the circular shapes versus the tree shapes I've just talked about, still considered where is the root. There's some may be different and how they extend branches and leaves. And again, consider these features. Now you can go to the last word. You see why this enclosure diagram not be put on the second one? Why not put on the circular shapes? You think about enclosure diagram. What's the difference? And so instead of putting that as shape, the shape may not really represent what they feature. First is circle packing layout. I only use this one image that you say, did you waste the time? No, because you are showing the classes, subclasses, and but the issue is if you click any of that changes, everything rolled around. You have to spend some time figure out where I just found, right? Where I go for that. So this is the issues. The branches and leaves change dynamically. Same space, keep changing, and people have to look around and then think. I think that's Tanya finding also, whether people don't like it, right? This is circle packing layout. Is remembered. Tree maps. It's the original looked like this, and you wasted space. Now you go with a whole tree map. Space contain the visualization of the hierarchical structures. So enable users to compare nodes. So which one is bigger, which one is smaller, and then help them spot out. Very effective and easy to understand. And it can show huge amount of data. Who is using that? Every day, there is a frenzy about the stock. Every day, you can see the color shows like the Microsoft, whether this today is up or what's the history. And you can also see other specific smaller ones. It's quantity-based and update every day, maybe even more than day to show. So these tree maps are very effective and used. However, where is the root? And you find out the root of that. In general, this whole thing comes from the root, the branches and sub-branches. and the title represent what the root is. Okay, so that's the enclosure diagram. In general, that we can see all of those different ones, not only think about the root, branches, leaves, but also consider their features. So you can extend with people find this usable and readable, and you feel comfortable not looking around, but easily follow. Right? So in general, we can see the visual representation reflecting the order and structure of knowledge. And they are already used for more than 2,000 years. The modern computerized visualization and computer-assisted graphic creation offer great potential, while the usability issues still need to be addressed. Not just the display, not just the put things there. So it's important to pay attention to the functions of visual representation methods and layout that enable consequential information discovery and ultimate user experience in the data-driven age. That's my major references that I had used for getting that. There are lots of good, and the images I use in the framework. And also I had mentioned that I have all the details, even trace the root in my website that I use for teach. So if anyone would like to get the password, just let me know. I'll write to you right away. Okay. All right.